Good morning, students. So today we'll be continuing with the same chapter, control statements in C++. So in today's topic we will learn about concept of loops, and in concept of loops there is one loop called as for loop. So we shall see what is for loop, and then I shall explain some programs on this for loop. All right. So what is loop? So whenever a section of the program needs to be repeated a certain number of times, a loop is used. So a section of the program, okay, not all of the program, that means mostly related with the program logic, the formula. So the repetition continues as long as the test condition or the expression, which is a boolean expression, it may be true or false, like that, right? So when it is, as long as it is true, that condition will be executed. But when the test condition becomes false, the loop will stop, clear, and the control will pass on to the next statement after the loop. So the test condition, as I said, is a boolean expression, which is a relational expression. So as long as the test condition is true, the loop will keep on repeating. But when the test condition becomes false, then the loop will stop automatically, and then whatever is written below that loop will be executed. So the next statement after the loop will be executed. Okay, so we have different types of loops. There are three types of loops, that is for loop, while loop, and do loop, or also called as do while loop. So today we shall see what is for loop. Now, for loop, the for loop is used when the statement enclosed within the body of the for loop is repeated or iterated several times depending on the condition. So if you can see here the format of the for loop, okay, so the for loop, it will be used when this program statement, or this it may be a single statement, or it may be a compound statement, it may be a formula, or it may be a cout. Okay, a cin also will be there, cin bootstream also will be there. So when you need to repeat this program statement again and again, then you use the for loop. Okay, so it will be based on this condition, that is these three conditions. So if these three conditions if this condition holds true, then this body of this, or this program statement, will keep on repeating, will keep on executing. So the test condition in for loop needs to be finite. The number of repetitions needs to be known in advance, or the loop will execute infinitely. So this is the continue condition, is test condition. So in a for loop, this test condition must be finite. That means it should stop at a certain point. It must become false at a certain period of time. If not, then the loop will keep on executing infinitely, which is results in like a logical error, which is unacceptable. Clear? Your program will keep on running, will keep on just running. So that is not the desired output that we want. So always the loop, be it for loop, while loop, or do while loop, okay, it must stop at a certain point. So you must, so based on that, okay, the condition, the test condition, should be written in such a way that it will stop at a certain point. Yeah. So as you can see, the format of the for loop, for, and within this parenthesis, okay, within this parenthesis you have what is called a start condition. So this start condition is, this is an initialization expression. So it is an expression. Okay, so that means you're initializing a variable. So it initializes the counter variable. What kind of variable? A counter variable. This counter variable is used in loop. You will see, so it is a special variable, okay, which is always used in loop constructs for initialization, test condition, and re-evaluation, that is increment or decrement. So since this counter variable is used only in a loop, so you use it for the start condition, you use the counter variable in the continue condition, and you use the counter variable in the re-evaluation also. So that means this counter variable is very important and it's very special. So the first part is the counter variable is initialized, so which indicates starting the loop to initial value, and initialization is done only once. So if you have to start the loop So there must be a starting value so that the loop will continue, so that the loop will start. Okay, so that's why initialization is very important. So the counter variable, suppose the name of the counter variable can be used as ctr, or most in most of the program it is used as I, the alphabet I. So I should be initialized, that suppose like I equals to 1 or I equals to 0, like that. Okay, so only when it is initialized, then the test condition can be done, because the test condition is done using the counter variable, and also the re-evaluation, that is the increment or decrement, is also done using the counter variable. That is something like suppose like you are at you are standing in a particular place, okay, and then say like you are, let's say you are at the front of your door, right, front position, front of your door, and you want to go to say like the grocery shop, and let's say that the distance from your house door to the grocery shop, if you walk the distance, it's say like in 100 steps you reach that, right? So your starting position is right now 0, that is your initial position, right? So if you move one step forward, then if you move one step forward, that means you're moving one step forward, so let that be considered as uh, distance number 1, because uh, you estimated that from your doorstep till the grocery shop, it takes 100 steps, right? So if you move one step forward, that is step number 1, right? If you move again another step, that is step number 2, like that, right? But if suppose you are the initial point is 0, now if you move backward, then it is like -1. If you make a second move backward, again that is like -2, right? Now if you come back to the original position also, then that is like -2, -1, 0, right? But still then you have moved the step, right? So it cannot be undone, like that, right? So in order to start the loop, okay, that initial value must be given. So suppose like if you give, suppose like the counter variable, suppose like the counter variable is I goes to 0. Now because of this re-evaluation, that is increment or decrement, the counter variable can never come back to the initial position, because it will either increase or decrease, that is like from 0 it will move on to 1, 2, 3, 4, or from 0 it will move on to -1, -2, -3, like that. It can never come back to the initial value, that is 0 or 1. Clear? So that is why it is called as initialization is done only once, and initialization is very important because it is needed for the continue condition and re-evaluation, and also for this program statement to repeat. So that is done first, okay, this is done first. And in the second case, after you initialize the value, right, that is like after you enter the value, right, so it is an expression, so that means you are using the assignment operator. Since it is initialization, that means you are using the assignment operator to assign a value to the variable, that is like I equals to 0. Okay, now continue condition is the second step that will be done in the for loop. So this is the conditional test expression that decides whether to enter the loop. That means if the condition is true, then you can execute this body of the loop, you can enter inside the loop, or as long as this condition is true, you can continue execution of the loop. That means the body of this loop will keep on continuing. Clear? So the first case is if the condition is true, then you you can enter into the loop, so to repeat this, so to execute this program statement. Or if the condition, after you increment it, if the condition is still true, then you can continue execution of this loop. Okay, or if this condition becomes false, then the body of this for loop within these curly braces will stop execution, and it will come to number 5, that is the end of this loop, and then it will move on to the next statement. So re-evaluation, so it changes, increases or decreases the value of the counter variable after the body of the loop is processed each time. So this is step number 4. So this is step number 3. First initialization, then test the condition, then the body of the loop will be executed. If it is true, the body of this program statement will be executed, and then after that it will come to here re-evaluation. That is, in order to move one step forward, right, and in order to test the condition. So here after the body of the loop is processed each time, so in order to continue this looping construct, okay, this increment should take place or decrement should take place. So that is, if you are moving from your position 0 to 1, right, so that is plus 1. Again, if you are moving forward step 2, that is again plus 1, like that, right? So when you reach 100 steps to do the grocery store, so you are adding every time you're taking one step, you're adding it by one number, right? Plus 1, 2 plus 1, 3, 3 plus 1, 4, 4 plus 1, 5, like that, right? So by that time you're able to add those numbers, right? So that is done in this re-evaluation by using the increment or decrement operator. Clear? Program statement. So this is the statement block that is repeatedly executed until the continue condition becomes false. So this is the step number 3. So always remember in the for loop, okay, the first is the initialization, second is the test condition, third is the program statement, fourth is the increment or decrement the counter variable, and fifth will be if this continue condition, test condition becomes false, it will come to the fifth step, that is the end of the for loop. Clear? So let's look at an example of for loop. Okay, here write a program to print first 10 natural numbers. So the program is asking us to print out 10 natural numbers, that is the natural numbers 1 to 10. So this is a series that must continue, right? So after 1 it should display 2, after 2 it should display 3. So you can see that every time it increments by 1. So 1 plus 1 2, 2 plus 1 3, 3 plus 1 4. It is in a constant step, right? So as usual, it will always start with the header file and then the main function, and this is the main function body, okay, within this opening and closing braces. So you are declaring the variable CTR. Now CTR is the counter variable, which is also represented by the alphabet I. So later on in the other programs, you will see that mostly instead of this CTR, the name, okay, we will be using this variable I, the alphabet I. Okay, so you are declaring that variable. Now keep in mind that the counter variable is used in the loop only, okay, not in any other blocks, but only in the for loops. Okay, so here you can see that the test condition for CTR equals to 1. So now this is initialization, okay, start condition. So here you are assigning the value 1 to the counter variable. So because here you have to print the first 10 natural numbers, right? And the first natural number starts with 1. That is why the initialization value is 1. All right, so that is assigned. Now after 1 you cannot go back to again the same number 1, but it must move forward from 1 to 2, 2 to 3, which is taken care by this. Okay, so after this initialization, second will be test the condition, which is 1 less than equal to 10. Okay, so here also we are using the relational operator less than equal to 10. So as long as this condition is true, this the body of this for loop cout CTR will keep on displaying the value. Clear? So here you can see that I have written here less than equal to. Now why not less CTR less than 10? Because if you make it CTR less than 10, right, so it will, the loop will continue only 9 times. That is, 1 is less than 10, 2 is less than 10, 3 is less than 10, 9 is less than 10. So when it becomes 9 is less than 10, the loop will continue only 9 times, and then you will get the output only from 1 to 9. Because when it becomes 10 is less than 10, that will be false, and you the output will be printed out 1 to 9 only. But the question is asking first 10 natural numbers, right? So that's why the less than equal to operator, relational operator, is used, not CTR less than 10, but CTR less than equal to 10. Clear? So here CTR is initialized only once and must be initialized to start the loop. So CTR less than equal to 10 is Boolean expression. If true, body of the loop inside these braces, that is in this one, okay, will be executed. So value 10 is used to stop the loop. So here you can see that, as I said, infinite loop is cannot be results in error, right? So the test conditions should stop at a certain point. So that is, we can find out by the program. Okay, so since it says here 10 natural numbers, so that's why the value 10 is written here. Clear? So you cannot use so here the value 10 is written here, so that the loop will continue exactly 10 times. If it is written here first 20 natural numbers, so you will write here 20, because the loop should continue 20 times. Clear? So this test condition becomes finite, so that means it will become false at a certain point. So now, since this test condition is true, 1 is less than 10, cout CTR, so it will display 1, and then this is a null string, so that means this null string which occupies one character, 1 byte, right? So it because of that, okay, there is a space between 1 and 2, so it this null string will create a space between the number digit 1 and 2. If suppose you don't use this, okay, if suppose you remove this one, okay, and just you say cout CTR semicolon, then you will observe that there will be no space between 1 and 2. Clear? So you can try that in typing out this program. Clear? So after this step 3, the fourth step will be this one, which is CTR equals to CTR plus 1, or it is CTR plus plus. Okay, so you are incrementing it by 1. So is incremented or decremented by 1 to continue test condition until it becomes false. So this is incrementing is done so that this test condition must be proven false. So otherwise the loop will keep on continuing, right? So why in here I'm writing down CTR plus 1, but if suppose let's say that you want to print out even numbers, right? Or say you want to print out, say like the numbers, yeah, suppose like 2 4 6 8, like that, right? In that case, here it will be like CTR plus 2, so every time you will jump two numbers, like that. So that way it will print out the numbers 2 4 6 8, like that. Yeah. So this body of the loops, okay, body of the loop repeatedly executed until false. So now once this gets incremented by 1, CTR will be, the present value of CTR is 1, right? So that is CTR equals to 1 plus 1, 2. So 2 will be stored in this variable, counter variable CTR. Like since CTR is a counter variable, but yet it is a variable which stores data temporarily, right? So once this formula is executed on the right side, and that value which is obtained will be assigned to on the left side variable. So CTR now will become 2. So 2 is less than 10. Yes. Then again this body of the for loop will execute, and it will display cout CTR 2. Okay. So this will keep on going till, okay, CTR becomes suppose like 9. Okay, so 9 plus 1, 10. So it again, it will come here, it will test the condition. Okay, so after this is done, step 4, it will come back here to test the condition. So CTR, what the value of CTR is 10. 10 is less than equal to 10. Yes, then it will come here, cout CTR, what value stored in CTR? 10. So it will print out 10. So it will print out all of this value. Then after that, CTR again will get incremented by 10 plus 1, 11. Then it will test the condition. 11 is less than equal to 10. No, right? Then it will come to it will stop execution of this body of the for loop. It will come to the closing bracket and then execute the next statement, that is terminate the program. Clear? So type out this program and run this program and check, make some changes here. Okay, say like you try removing this equal to sign, or you change this value from 10 to 20. Okay, or you try changing this 0, okay, 0, and then you try changing this CTR plus 1 to CTR plus 2, and see see what changes in output you will get. Okay, So now nested for loop. In nested for loop, two for loops are used. One for loop which is called as the inner loop, okay, and another is written inside the body of another for loop which is called as the outer loop. So the inner for loop will be evaluated first, it will be executed first. Okay, so here another program to print the multiplication table from 1 to 10. So here you have to print the output like this, okay, like 1 into 1 equals to 1, 1 into 2 equals to 2, 1 into 10 equals to 10, 2 into 1, 3 into 1, 4 into 1, okay, till 10 into 10 equals to 100. So that means you have to print out the multiplication table from 1 to 10. So though the output is a lengthy output, yet you can see but that just by this program length, small program length, you are able to print out all of the multiplication tables from 1 to 10. So you can see the advantage of using the for loop, the loops, right? If you have to use a normal C++ program, okay, then it will become a very lengthy program. But by using the for loop, you can see that because only this program statement, these two lines of statement, that is this compound statement, has to be repeated again and again, and based on these two program statement, the output will be printed out again and again, right? So but here you can see that you are using two loops. So this is called as the outer loop, okay, outer for loop, and this is the body of the outer for loop. Okay, so in the body of the outer for loop you have another for loop. So this for loop is called as the inner for loop, which is inside the body of the outer for loop, that is this opening bracket and closing braces. Okay, so the body of the inner for loop contains actually the program logic. Okay, so the program logic. So always the inner for loop will be executed first. After that, once this becomes false, the outer for loop will get executed. Again after that, the inner for loop will be executed next, and then once this becomes false, the outer for loop will get executed. So this will keep on going till the outer for loop test conditions become false. Clear? So as you can see that three variables are declared, I, j and k. So the outer for loop uses the counter variable I, and the inner for loop uses the counter variable j. Clear? So here starting with this for loop, for I equals to 1, okay, so since we have to print out the multiplication table from 1, right, so that's why I is initialized to 1, and then till the multiplication we have to print out till 10, right? So that's why the test condition is till 10. So this will keep on this will keep on continuing for 10 rotations or 10 repetitions. The loop of this the body of this outer for loop will repeat 10 times. So by that time 10 multiplication tables will be printed out. Okay, so first when this program gets executed, initialization will be done, then the testing of the condition will be done. If this is true, the body of the outer for loop will be evaluated. So in the body of the outer for loop, again the inner for loop. So here for, okay, this is j, okay, j equals to 1, initialization will be done. Okay, then j less than equals to 10, again same, because the multiplication table is like for one multiplication table is 1 into 1 equals to 1, and then the last one is 1 into 10 equals to 10, right? We do not have like so based on that, here also the stopping point for that loop is 10. So that means you get the multiplication table from 1 into 1 to 1 into 10, like that, or 2 into 1 into 2 into 10, or 10 into 1 to 10 into 10. Clear? So after initialization and test the condition, if this is true, then the body of the inner for loop gets executed, that is k equals to I into j. So now I value is 1, right? I value is 1 and j value is also 1, so which is 1 into 1 equals to 1, which is stored in k. Clear? So the outcome of this is produced by this cout. So cout I, which stores the value 1, right, and then within the string the asterisk symbol is there, right? So into will be displayed. Again j, now j stores the value 1, right, so that will be displayed. and then after that, using the cascading operator within the string double quotes, okay, equal to symbol will be displayed. Clear? So whatever is written within double quotes, it will be simply displayed as it is, right? If you write here 1 plus 1 equals to, then it will show 1 plus 1, but still you'll be getting the output 1, not 1 plus 1 2, right? Because whatever is written within the double quotes will be simply printed out as it is. Okay, so equals to k, so which is 1. Clear? Then /n escape sequence character, so the cursor moves to the next line, so the next output will be produced on the next line. Clear? If you don't use this /n, 1 into 2 will be produced in the same line. Clear? And then you get the multiplication table in horizontal, as a horizontal result, not in vertical format. Clear? So you have to use this /n at the end. So after this test, body of the inner for loop gets executed, I will get incremented. Okay, then I will become sorry, this is j. Okay, j will get incremented, that is j equals to j plus 1, so j becomes 2. 2 is less than 10. Okay, so again it will come here, the body of the loop, k equals to I. What is the value of I? I still stores the value 1 because we have not changed the value of I, right? A variable will store the value as long as the program is running, or if the value of in the stored in the variable is not changed, right? So I still stores the value 1, so it will be 1 into, but the value of j is changed from 1 to 2, right? So it will be 1 into 2. So when you run the C output stream, okay, it will display 1 into 2 equals to 2. Now this will keep on going till the value of I becomes 10. Okay, 10 is less than equals to 10, yes, then it will be k equals to 1 into 10. So Cout will display 1 into 10 equals to 10. Okay, now after that I will get incremented, so I will become 11. 11 is less than 10, no, right? So it will come to the end of this so this for loop becomes false, so it will come to the end of these braces. Okay, and then since this is the body of the outer for loop, okay, the outer for loop test condition is still true, right? 1 is less than 10, so now it will not come here, it will go here, and then I will get incremented by 1, so 1 plus 1 2, again it will be tested. Okay, so 2 is less than 10, yes, then the body of the for loop inner for loop will get executed. So now again for j equals to 1, j will still retain the value 1 here, because now again we are starting the inner for loop fresh. Okay, so j will retain the value 1. Now previously j was storing the, when we came out of this loop, j was storing the value 10, right? But when again when I becomes 2, okay, and the test condition 2 is less than 10 is true, after it executes the body of the loop, when it comes to here, you can see that j will not start from 10, because why? Again j is initialized to 1. Okay, so that is how initialization works. So j will become 1. So when this formula gets executed, k equals to I. What is the value of I now? I is not 1, but I is 2, right? 2 into, but j is 1, right? So 2 into 1, Cout will display 2 into 1 equals to 2. Okay, again j will get incremented by 2 by 1, j equals to 1 plus 1 2, so j will become 2. 2 is less than 10, right? Again it will come here, k equals to I value is 2, right? 2 into j value has become 2, so 2 into 2, it will display 2 into 2 4. Okay, so this will keep on going till I value becomes 10, which will be 2 into 10 equals to 20, right? After that, when j becomes 11, 11 is less than 10, false, then it will stop execution of the inner for loop, and then it will increment the value of I by 1. So which the previous value of I was 2, so it will become 3. 3 is less than 10, so now it will start a multiplication of 3. So this will keep on going till I becomes 10. So 10 is less than equal to 10. Okay, so then the inner for loop will display the multiplication of 10. Clear? So this way you get all the multiplication tables from 1 to 10. Clear? So type out this program also. Okay, make some changes here. If you suppose you write here I equals to 0 and j equals to 0, you will get the multiplication table of 0 also. 0 into 0, 0, 0 into 1, 0, 0 into 10, 0, like that. Okay, and try changing this value. If you change this value here from 10 to 5, 5, okay, you will get the multiplication table of 1, say like 1 into 1, 1, 1 into 2, 2, 1 into 3, 3, 1 into 4, 4, 1 into 5, 5. You will not get 1 into 10, 10. Okay, but it will be till 5. And even for 10, it will be 10 into 5 equals to 50. Clear? So like that you make some changes in the program logic. Okay, instead of I plus plus, you can also try I minus minus, j minus minus, like that. Clear? So next is use of comma operator. Now we can combine two expressions using comma operator. So like in this example, see here, if you can here you can see that initialization of the two counter variables are done at the same time. I equals to 1, j equals to 1. That is by using the comma operator. Yeah, one more thing is that the test conditions, okay, all the test conditions, that is I, j, this start condition, okay, test the condition and reevaluation, is all separated by semicolon, not comma. Okay, only when we combine two counter variables, then we use the comma, like here. Okay, so I plus equals to 2, which means that I plus equals to 2, which means that I equals to I plus 2, which means that the counter variable is incremented by 2 every time. Clear? And j minus equals to 2 means j equals to j minus 2, which means that the counter variable is decremented by 2 value every time. Okay, so the counter variable, you can see that two counter variables can be initialized, two counter variables can be tested, two test conditions can be done using the comma operator, and two increment or decrement can be done using the comma operator. Okay, similarly, variable declarations can be done inside the for loop. So we can also declare variables inside the for loop. Not all variables needs to be declared after the main function. In all the programs we have seen that right after the main function we are declaring the variables, right? But later on you will see that, and from this program you will see that, okay, you can also declare the variables inside the program, anywhere in the program, provided it is declared before it is used. So here, instead of declaring the variable I at the top of the program, okay, just before you use this variable, you can declare it in the for loop itself, like int I equals to 1, int j equals to 1. So once you declare this variable here, okay, you don't need to declare the variable like here int I less than equal to 5, like that. Clear? So try implementing this int I, declaring this variable in that program which I just explained. Okay, so this is the first part of the looping construct, that is the use of for loop. Okay, so this is the mostly widely used loop, okay, among all the loops, that is while loop, do while loop. Okay, so for loop is, you will see that the for loop is used in almost all of the programs. Clear? So try to understand the format of the for loop very nicely. Okay, there's 3 points. Okay, because you'll be using this a lot, okay, in all in the programs that you'll be seeing in the upcoming chapters. Clear? So that will be all for today.